Well, hello everyone and welcome to Mathematics Tutorial 14, the first in a series of two tutorials on integration. So by the end of this tutorial, you will know and understand about the process of integration and how that when we integrate something, this is the opposite function to differentiation that we've previously studied. And you will know how to integrate a variety of polynomial functions using a fairly simple rule. We call this integration by rule. And it's very similar to the differentiation by rule that we studied at the start of the differentiation section. So the first question is, what is integration? Well, it can be used to find areas, volumes, central points, and many other useful things. It's the opposite process to differentiation. You'll remember that in differentiation, we were trying to think about the rate of change on of a function. Now, we might be interested in taking that function and trying to work out what the area between a function and the x-axis is. So in this case, the area underneath this curve in the direction of x. Now we could calculate the function at a few points and add up the slices, and each of those slices would have a width of delta x. And we could progressively make those slices smaller and add up lots and lots of tiny slices, and it would give us a reasonable approximation of the area under that curve. However, it wouldn't be very accurate. Now, if we were to allow those slices to approach 0 in width, we'd have an answer that approaches the true area underneath that curve. And you'll note here that we write, instead of writing delta x, we now write dx. Now that's a lot of adding up. It's a very laborious process, but there is a shortcut, because here finding the integral is the reverse of finding a derivative. Let's think about this simply. Let's take a nice simple example to start with. An integral of 2x is x squared, and the derivative of x squared is 2x. So you can see how we're doing the opposite things in each case. If I differentiate x squared, it becomes 2x. If I then integrate 2x, it becomes x squared. And I'll talk a little bit more about that plus c bit later on. Now you can prove this quite nicely if you think about the x squared example as the area underneath the triangle. We know that the area of a triangle is equal to half its base times its height. So in this case, if we were to multiply x by half and then multiply that by 2x, the value we would get is x squared. So you can see how you can start to think about calculating areas underneath curves using integration. The notation of integration looks a little bit more complicated than differentiation. There's a somewhat stylish S symbol at the very front. This is the integral symbol. After the integral symbol, then we put the function that we want to find the integral of. So in my simple case here, it's 2x. And then after that, we finish it with a dx, which basically is saying that we're going to integrate with respect to x. So you can see at the bottom there, I've got my integral function, followed by the function that I want to integrate, 2x, followed by dx, and I'm saying that that's equal to x squared plus c. Now, where does that plus c bit come from? When we integrate 2x, we get a value of x squared, but we wrote a value of plus c next to it. And This is called the constant of integration. It's there because of all the functions whose derivative is 2x. Now think about that. The derivative of x squared is 2x, but the derivative of x squared plus 4 is also 2x. Remember, we remove whole numbers when we differentiate terms. The derivative of x squared plus 3 is also 2x. The derivative of x squared minus 6 is also 2x. When we integrate, we've got no way of knowing what those numbers are. There could have been a constant of any value there. So what we do is we wrap that up by writing simply plus c at the end.
Okay, so let's have a little practice at some examples then, and let's just remind ourselves of the process of differentiation first of all. So if I try and differentiate this here, y is equal to 2x cubed plus 9x squared plus 5x plus 2. Now you'll remember that when we're talking about differentiation, we times by the power and we subtract 1 from the power. So if I attempt to differentiate now, dy by dx, here if I multiply by the power, I've got 2 times 3, which is equal to 6. And I take 1 off the power here is 3, so that becomes 6x squared. If I then differentiate the next term here, I've got 9 by 2, which gives me 18, and I take 1 off the power, so that becomes 18x. Then I move on to the next term. I've got 5x, so that is 5x to the 1, so I multiply by the power, so 5 times 1 now is 5, and I take 1 off the power, which will be x to the 0. Of course, anything to the power of 0 is 1, so I leave that out. And then I remove the whole number here. That we remove that when we perform the process of integration. So now what about, differentiation. Now what about integrating this expression? Let's think about how we spoke about that in the start of this tutorial. I want to find the integral of the expression I've just differentiated, essentially. 6x squared plus 18x plus 5, and I want to do that with respect to x. Now the process is the opposite to differentiation, so we are going to do the opposite. So what's the opposite of this process? Well, what I'm going to do first is I'm going to add 1 to the power, and then I'm going to divide by the new power. So if you think about the process of differentiation, which of course is multiplying by the power, well, I'm doing the opposite to that because I'm dividing by the power in the process of integration, and I also subtract 1 from the power in differentiation. When I integrate, I do the opposite to that and I add 1 to the power. So let's try and integrate this expression here. So that is equal to, let's deal with this first part initially, 6x squared. I'm going to add 1 to the power to generate 6x cubed, and I'm going to divide by the new power. Then we'll deal with the next part, 18x. that is of course 18x to the 1, so I'm going to add 1 to the power to give me 18x squared, and divide by the new power, divided by 2. And I've got plus 5 in my expression up here, so to integrate that, I need to add 1 to the power. Of course, that is 5x to the 0, so that becomes 5x to the 1. And I don't need to divide it by 1. And I'm going to add my constant of integration at the end here. Now, of course, in this one, we know that that constant was plus 2. But unless the question specifically asks us, we don't need to do anything about that. So we usually just write plus c. So let's have a look at some more examples now. Let's try and integrate this here. So find the integral of 9x squared plus 4x plus 5 with respect to x. So how do I go about doing that? Well, the first thing I do is add 1 to the power, so that's going to become 9x cubed, and I divide by the new power, and I can do exactly the same again, add 1 to the power and divide by the new power, and again add 1 to the power, no need to divide by 1 here, plus my constant of integration. Now what we didn't do in the last example was simplify, and of course we can simplify this quite nicely. This then becomes 9 divided by 3 is equal to 3, so that becomes 3x cubed, plus in the second part 4 divided by 2 is equal to 2, so that becomes 2x squared, and that remains as 5x. So that's the right answer for the second example there. So let's have a look at another example. Find the integral of 6x squared plus 3x plus 9 with respect to x. So again, I add 1 to the power, that becomes 6x cubed, divide by the new power. Again, I add 1 to the power, divide by the new power, and 9 becomes 9x plus my constant of integration. Again, we can simplify this slightly. So 6 divided by 3 is 2, so that becomes 2x cubed. The 3 divided by 2, we tend to leave that as a fraction. I mean, obviously the answer to that is 1.5, but we tend to not include decimal places, so we leave that as 3 over 2x squared plus 9x plus c. So let's try and integrate something that's a little bit more challenging. So let's have a look at this one. Find the integral of 7x squared plus 5x plus 10 divided by x squared with respect to x. Now, on first inspection, some of these terms look perfectly manageable. Okay, so the 7x squared term, fine, we can deal with that. The 5x term, we can deal with that. But it's this term here, 10 divided by x squared, which is perhaps a little bit more challenging. We can't integrate that simply. So we've got to write this in a way that is a little bit more friendly. And of course, we know that 10 divided by x squared is equal to 10 multiplied by x to the minus 2. So there now is a friendlier term with which we can integrate. So let's rewrite this now. So we are trying to find the integral of 7x squared plus 5x plus 10x to the minus 2 with respect to x. Now let's deal with each of these terms individually. The 7x squared bit initially, I'm going to add 1 to the power and divide by the new power. So that becomes 7x cubed divided by 3. Plus, add 1 to the power now. That's going to become 5x squared divided by the new power, 2. And again, add 1 to the power. So here I'm going to add 1 to minus 2. If I add 1 to minus 2, then it becomes minus 1, and divide by the new power, minus 1. Plus c, let's not forget our constant of integration. Now we can simplify that slightly. The first one we can't really simplify because it's not a it's going to lead to a decimal place, so that just becomes 7 over 3x cubed. Same again, 5 divided by 2x squared. Plus, now I can simplify this one slightly. Anything divided by a negative number is a negative number. So 10x to the minus 1 divided by minus 1 simply becomes, apologies, minus 10x to the minus 1 plus our constant of integration. So that's the answer to the slightly trickier example here. Let's have a look at another one. Let's see what we can do with this one. Find the integral of 6x squared plus the square root of x plus 3x to the minus 2 with respect to x. Now again, we've got something in here which doesn't look familiar to us, or is perhaps a little bit trickier to think about. It's this square root of x term here. Now again, we know that the square root of x is equal to x to the half. So again, this now becomes a value with which we can perform integration. So if I rewrite this in a slightly friendlier form, find the integral of 6x squared plus now x to the half plus 3x to the minus 2 with respect to x. I can I can integrate this more easily. So in the first bit, what I'm going to do, 6x squared, I'm going to add 1 to the power. So that becomes 6x cubed divided by the new power. In the second part, I've got x to the half. I'm going to add 1 to that, so it will become 1.5, but we're going to keep it as a fraction. So it becomes x to the 3 over 2. And similarly, I've got 3x to the minus 2. So I'm going to add 1 to minus 2, which is, of course, minus 1. So that becomes 3x to the minus 1 divided by minus 1. And I forgot a divided by 3 over 2 here. Now we can simplify some of that. We can simplify all of these. The first one is easy. That's just 6 divided by 3 is 2, so that becomes 2x cubed. The second one is a little bit trickier. So let's pull this one out and see how we can deal with that. what we're saying here is that we've got x to the 3 over 2 divided by 3 over 2. Now, whenever we're dividing by a fraction, we can remember a simple rule. Keep it, change it, flip it. What do I mean by keep it? I mean we keep that first term, so x to the 3 over 2. Change it, I change the sign, so I multiply now, and flip it, and I flip the fraction. So what I'm saying is that x to the 3 over 2 divided by 3 over 2 is equal to x to the 3 over 2 multiplied by x to the 2 over 3. So we can rewrite that over here as plus 2 over 3 x to the 3 over 2. And in the final part here, I've got 3x to the minus 1 divided by minus 1. Of course, 3x to the minus 1 divided by minus 1 will give me minus 3x to the minus 1, plus my constant of integration, which I've forgotten up here as well. So that is the answer to that one.
Okay, so pause for self-test 1 here, have a go at these, and resume the video and I will go through the answers.
Okay, let's go through the answers to self-test 1 then. Let's start with 1.1, which asked us to integrate the following term: 3x squared plus 17x plus 10. So hopefully this should be quite easy by now. We need to first add 1 to the power and divide by the power. So again, add 1 to the power and divide by the power. Of course, there is an implied x to the 0 here, so this just becomes 10x. And we can simplify this slightly. 3 over 3 is 1, so that just becomes x cubed plus 17 over 2 x squared plus 10x. And I'm forever forgetting these constants of integration. Don't forget those. Let's have a go at 1.2. So that's 8x squared plus 2 times the square root of x plus 4x to the minus 3. Remembering we've got to deal with this bit first. Just going to put that into a friendlier format. Of course, 2 times the square root of x is equal to 2 times x to the half. So we can rewrite this slightly. So now we're trying to find 8x squared plus 2x to the half plus 4x to the minus 3, which is equal to, first of all, I will add 1 to the power, so that becomes 8x cubed divided by the new power, plus here 2x to the 1 1/2, so 2 times x to the 1.5, which will give me 3 over 2 divided by the new power, plus 4x. If I add 1 to minus 3, it becomes minus 2 divided by the new power. Some of these I can simplify. I can't simplify the first term, so that just becomes 8 over 3x cubed. This I can simplify. And again, if we think about what's going on here, and just come off to the side for the minute, I've got what is 2x to the 3 over 2 divided by 3 over 2. So I want to do a couple of things here. I've basically got, if you think about it, I've got 2 divided by 1 divided by 3 divided by 2, which of course is equal to, keep it, change it, flip it, 2 divided by 1 multiplied by 2 over 3. And 2 divided by 1 multiplied by 2 divided by 3 gives me 4 over 3. So that term simplifies to 4 over 3x to the 3 over 2. And finally I can simplify that very last term here. 4 divided by minus 2 gives me minus 2x to the minus 2. Apologies. Let's get rid of that plus sign. Let's have a go at 1.3 then. So we are asked to find the integral of 3x squared minus 6x squared plus x plus 1. So I've got here add 1 to the power in the first instance. So I've got 3x cubed divided by 3 minus add 1 to the power 6x cubed divided by 3 plus now an implied x to the 1 here. So this becomes x squared divided by 2 plus, again, remember there's an implied x to the 0 next to this 1, so it becomes 1x, or just x. We'll write 1x for clarity. And of course I can simplify these slightly. 3 over 3 becomes 1, so that becomes x cubed. Minus 6 over 3 becomes 2x cubed plus x squared divided by 2. We could write that as half x squared plus x. And the final example that we're given is find 3x squared minus 4x plus 10x to the minus 6. So again, this one's quite a simple one. And you'll notice, yet again, I've very naughtily forgotten my constants of integration. Please don't forget those. Let's have a go at this one. I'm going to add 1 to the power and divide by the power, add 1 to the power and divide by the power, add 1 to the power and divide by the power, plus c. There we go, I've remembered it this time. And that is equal, I can simplify that slightly, 3 over 3, so that's just x cubed minus 2x squared. In this case now minus 2x to the minus 5 plus c. And there are the answers to the self-test problems.
So that's all we've got time for. I'll see you in the next tutorial.